People get excited about numbers like pi, but there are lots of cool facts to see with the single digits. I'll show you one fascinating fact about each of the numbers from 1 to 9. The number 1. How many straight line cuts do you need to cut out this swan? With 11 edges, 11 cuts are enough. But if you draw the right crease lines and fold the paper the right way, you can do it with only 1 cut. 1 cut is enough for any polygon. Look in the video description for a link to try this yourself on several shapes. The number 2. Euclid showed that there are infinitely many prime numbers, but notice that some of these are just 2 apart. Are there infinitely many of these twin prime pairs? Nobody knows, but we think there are. The distributed computer project PrimeGrid found this colossal pair of twin primes. The search for twin primes uncovered a bug in a Pentium chip that cost Intel a boatload of money. The number 3. Are there always patterns you can find with a large number of points? With these 12 points, we can form 4 triangles whose interiors overlap. Birch's theorem says that for any set of 3 endpoints, one can form n triangles that share some common interior. The number 4. I'm sure you've noticed that a tennis ball or baseball is formed by 2 identical dumbbell-shaped pieces. Here's something you may not have noticed. Follow the seam and mark the points where the curve changes its direction of bending. There are 4 of these inflection points. The tennis ball theorem says that on any smooth curve which divides a sphere into 2 parts of equal area, there are always at least 4 inflection points. The number 5. Pick 2 numbers, say 4 and 7, and use these to form a sequence of numbers with this formula. This says that to get the next number in the sequence, take the previous number, add 1, then divide by the number before that. You see that the numbers repeat after 5 steps. In fact, almost any 2 starting numbers will produce cycling after 5 steps. The number 6. Let's look at a random group of 6 people. If 2 people have met, we'll say that they are friends, otherwise they are strangers. The friends and strangers theorem says that no matter what the relationships are, you must have either 3 of them being all friends or 3 of them being all strangers. The number 7. By writing the fraction 1/7 in decimal form, we see that the digits 142857 repeat forever. These other fractions, although each starts differently, have digits that eventually repeat with the same order. These digits can also be used to create 2 special ellipses, sometimes called 1/7 ellipses. The number 8. Take a standard deck of 52 playing cards. Split the deck in half and do a riffle shuffle, that is, alternately combine the cards. After 8 such shuffles, you would think that the deck is shuffled very well, but instead, you get the original ordering back. This works no matter how the cards were originally ordered. And lastly, the number 9. If you want to pack cans in a case, the standard hexagonal packing makes sure that there is no wiggling around. Is a tight packing with 2 different size cans possible? Yes, in fact there are exactly 9 different ways to do this. Want more from the numbers 1 to 9? Get my book, Single Digits in Praise of Small Numbers by Princeton University Press. Everything in this video and much more is in this attractive volume. Get Single Digits today.